All right, so this is going on page 33 when we're done. And we are going to just review our exponent rules, some of which you're very, very good at, some of which you get mixed up in things, okay? So the first thing is when we're adding and subtracting monomials. And a monomial means it's just a one-term thing, okay? So when we take 9x squared y minus 10x squared y, can I actually combine those? Yes, because the x squared y matches on both of them. If this second one was x squared y squared, then could I combine them? No. But when I do that, since they're the same, I basically just kind of ignore the x squared y. 9 minus 10 is a negative 1, so that gives me negative x squared y. Do we all agree with that? Okay with that? All right. Then it says subtract 6w from 8w. So the thing that worries me about sentences like this is because there's a lot of students that will say things backwards. Like, I don't know, like if I have two angles in a triangle and I want to figure out what the third one is, I add the first two together, and then students will say, then you subtract 180. Well, we're not subtracting 180, right? We're subtracting from 180. So making sure you can actually interpret this correctly, we've got to make sure we can do that. So subtract 6w from 8w would be 8w minus 6w, and that gives you what? 2w. Okay. I'm not so worried about that concept right there. I think combining like terms is something that we hopefully do actually have down and we'll be fine with. All right. So then on to the product rule. I'm multiplying two bases, and what do I do with the exponents? Add them. So this becomes x to the a plus b power. All right? So that means here, h squared times h to the 6th would be h to the what? 8th. Okay? Then here, where I have a bunch of them, the coefficients that don't have exponents on them, I literally just multiply them, so that would give me a negative 14. And then a squared times a cubed is a to the what? 5th. And then b what? Squared. Okay, so, and I think you're okay with that stuff too. But what if I have, let's see, we'll do it right here. 2 to the x times 2 to the y. What's my answer? 2 to the what? X plus y. It's the same rule, right? It doesn't have to be a number in the exponent. It can be a variable. Whatever it is, you're adding them. Okay? That okay? You okay with that? You do not, no, because here I didn't get x squared to the a plus b. Does that make sense? Because that's why I'm showing you that. It's a very good question. Thank you for asking that. So if I hit 5 to the 2nd power times 5 to the 3rd power, I'm not going to get 25 out of any of that. The base stays the same, and I add the exponents, that would be 5 to the 5th. So the base stays the same. The base stays the same. Thank you for saying that, because that is a common mistake. That doesn't become 4. Okay? We good on that? Base stays the same, so maybe we need to write that. I think you have more room off to the side because of the way that it printed. So we can say, actually, for all of these, it's really true for all of these. And it, do not change. Okay, so we can say base stays the same. We'll put it at the top even. Base stays the same. Okay, base stays the same, because that is where people start making stuff up. Everybody good with that? Okay. Thank you for asking a question. All right, so then our product rule. I'm sorry, not our product rule, we just did that. Our power rule. If you have a power to a power, hang on. So I'll have to keep doing that. A power to a power, that's when you multiply them. This is x to the a times b power. So x to the 2 times 3 power is x to the what? 6th. Okay? And if you have more than one thing that you are taking to a power, so that whole thing is to the 2nd power, I have to do negative 2 to the 2nd power. What's negative 2 to the 2nd power? 4. And it's a positive 4. And then m to the 5th to the 2nd power is going to be m to the 10th, then times m cubed, which would give me 4m to the what? 13th. Very good. So let's again do one with like 2 to the x to the y power. It would just be 2 to the xy power, right? You're not, the 2, just the base stays the same no matter what you're doing. All right, quotient rule. When we multiply, we add. So when we divide, we do what? Subtract. So this would be, it's not a, sorry, x to the a minus b power. Our coefficients that do not have exponents on them, we just straight up divide them. So I've got 27 over 42, okay? I don't have to simplify the entire thing all at once. I know that they're both divisible by 3 at least. What's 27 divided by 3? 9, so we're going to leave 9 in the numerator. And then 42 divided by 3 is 14, good. So 9 over 14, can I even reduce that anymore? No, so it's going to stay like that. Then this x is really x to the 1st. X to the 5th divided by x to the 1st, 5 minus 1, I get x to the 4th. And then that's my answer. Y squared to the 2nd power is going to give me y to the 4th divided by y to the 4th. Does that give me 0? No, it does not. They cancel out, and you get 1. That's like saying 3/3 is 0. It's not, it's 1, right? Same thing with variables there. So if I have 2 to the x divided by 2 to the y, do I get to cancel the 2's out? No, I can't cancel them out because the powers are different. This would be 2 to the x minus y power, whatever it is. The base stays the same. And they have to match in order to do this, right? It has to be the same base. Everybody good so far? When we get here, yes, it is the flippy thing. The flippy thing, or in other words, when you have a fraction and you do the flippy thing, what's the fancy word for the flippy thing? Reciprocal, yes. It's okay. You got it. Just make sure we actually know the real words. I'm okay with flippy thing. All right, so when you have a negative exponent, that you get the reciprocal, but you don't always have to think about actually flipping it. In this case, x to the negative a would be 1 over x to the a power. So then I have negative 5 times x to the negative 2. Notice here, I had parentheses around this with the 2 on the outside. That's why I squared that negative 2. Does this exponent of negative 2 have anything to do with that negative 5? No, it does not. So it's just negative 5. That x to the negative 2 goes in the denominator, which would be x squared, like so. Okay, you with me? If it's in the numerator, you put it in the denominator. If it's in the denominator, you put it in the numerator. And if it doesn't look like a fraction, think about it over 1, and that's how you move the stuff. Okay? We good with that? Hello. All right. Here's what we got to be sure we don't do, and we usually don't do it with, there you go, put that over there for her. We usually don't make that mistake with simple numbers like this. Oh my God, it's a roach. It's screaming like it's a mouse or something. All right, so 4 over 8. I know that 8 divided by 4 is 2. Do I put 2 in the numerator? No. And I know you know better, but those are weird things that happen. And then I get, when I do my 2 minus 5, that gives me a negative 3. So that if I put it in the numerator, I'd have k to the negative 3 power. But I can also just leave it as k to the 3rd down here. We don't have to get crazy with the stuff. But I still have a numerator of 1. Okay? Everybody okay with that stuff? All right. Now, The other way that this negative exponent, what you really have to be able to understand is if I have like 2 to the negative 1 power, what would that give me? 1 over 2, it's 1/2, right? 2 to the, if I have 3 to the negative 2 power, so you don't necessarily have to rewrite a bunch of steps, but I'm just going to step you through it. This is the same thing as 1 over 3 squared, and what's 3 squared? 9. So, oops, well, I'm writing 9. It gives me 1 over 9, okay? Because sometimes we understand it with variables, even though I know you'd rather have numbers than variables. This stuff makes sense. We throw numbers in there, and then you make up stuff, and you're not sure what's going on. Okay, everybody good with that? Anything to the 0 power is what? 1. Okay, it's 1. Oh, nice. There we go, 1. So if I have 57 to the 0 power, what is that? 1. 7 times x to the 0 power, is my answer 1? No. This actually gives me 7 times 1, which is just 7, which you can leave off the times 1 part. But the 0 isn't on the 7, it's only on the x. Okay? And if we think about this quotient rule, so w to the 4th squared would be w to the 8th over w to the 8th, right? My quotient rule says I subtract, so this would be w to the 8 minus 8, which is 0, which is another reason it's 1. You don't have to put that, like here we just canceled it out and got 1, and that's okay, but really like that's the why behind it. What questions do you have? Do these all sound semi-familiar? Okay, so what I'm going to do is I'm going to give you what I want you to work on. We're going to work through a couple of these together. I just figured it was better than just notes. And then I'll tell you what you're going to do moving forward with that. And then hopefully we can move on from this. Yes. Oh, yes. I'll take it. I forgot. I haven't really taken stuff up from y'all. Actually, you can just hang on to it. I'm going to hand it all back out because I didn't actually grade it. I just kind of gave y'all grades this time. All right. Let me see. Let me put this in Sophia's folder so I don't forget. All right, here's what we're going to do. I'm not going to start with the super easy ones. I'm going to, y'all can do the super easy ones without me, right? I hope. We're going to start with, really none of them are crazy hard. We're going to start with number 12, okay? Because there's no reason to get cocky and be like, oh, I can skip all these steps because I totally got this. I wouldn't do that in these cases because it's so easy to mess up. Like the concept isn't crazy hard, but really easy to make a mistake. So I've got this whole thing in these parentheses is to the negative 3 power. So my first thing I'm going to do is I'm going to put 1 over, and then I rewrite it, 6c times d to the negative 1 to the 3rd power. Do you see how it only changed the negative on the 3? It did not change the negative on the negative 1, okay? Because that exponent belongs to that, we moved it down here. So then the next thing I'm going to do is I'm going to actually cube the denominator. This is a mono